Welcome you all to this fifth day afternoon session. Am I audible? Are you there? Okay. So, any question from the earlier part? If and you today we started with basically the problem which had been given to you as an assignment. Thereafter, we basically covered the frequency domain part. And what is basically the filtering in the frequency domain, which requires basically to do the Fourier transform, 2D Fourier transform of image. And then we we use the filter. When we are basically using the filter, actually we multiply it. It is almost like the convolution. Convolution in the time domain becomes a multiplication in the frequency domain. And even at the analogy levels, what we are seeing in the spatial domain, that when we are using the mask, actually, you are using the mask and has been moving that mask over the entire image. Here, see, actually, we are using the filter. Filter directly, we are multiplying in the frequency domain. So, depending upon what do we want to extract out from the image, what type of features do we want to extract out, whether it is basically the, for example, many changes are there, fine changes, right? Fine changes, actually, these are, for example, you take about the facial expression. See, my actually research work, my PhD thesis was also on the this facial expression only. And see, at that time, actually, I began to learn about that image, etc., image processing. So one important thing which came out that if you want to take out that facial expression, you need the higher frequency. And if you want to capture the image, that is basically at the lower frequency. Why does it happen? It happens basically primarily because your face actually, there very less variations are there. But when you talk about the facial expression, for example, lips movement, eye movement, there actually it's the uh, major movement and very fine movement. So that is the first time that I learned about basically the frequency concept in the image processing, and that really helped me a lot while during my thesis. And so that part we continued, and thereafter we also dealt with basically the image morphology, morphological operations. See, what do you mean by the basically the morphological operation? In morphological operations, see, here you are, see, for example, I want to alter the some part of the image, right? See, image enhancement is one part, that is from the appearance part. Compression is okay for transporting the thing. But for example, I want to do the some changes. I needed that. Can I bring the some change? I want to alter the image. So what are the processes? So that process are basically the morphological image processing. So what did we do here? Different type of processes were there. For example, dilation is there. See what happens in the dilation. Dilation basically you have been extending. And remember, important thing that this morphological, it happens only in case of a black and white figure only. So, which we call the binary image also. So, in that, the different type of operations we read about. For one was basically the dilation, another was basically in dilation. What you are doing, you are basically expanding that region. Which region? So, this one. Basically, in dilation, what you are doing is add pixels to the boundaries of foreground. Foreground basically the white objects in an image. What we are saying is structural element is slide over the image if any pixel in the. So what is happening here? If you see here really, that has been actually expanding from here to here. But how does mathematically? So what does it lead to? It leads basically process of expanding image, increase brightness of image. Can we understand from this figure? Yes, see, we can very easily understand. See, if you really see here. If, for example, this length is there. For example, any length is there. You take nearby here. This length is T1, and this length, corresponding length, it is basically the D2. So remember, D2 is necessarily greater than of D1. So that we are saying here. That is basically the dilation, that this white part that has been increased. That's in the foreground. So how does this mathematical operation take place is that you can see here easily. For example, this example is given for original image is there. This is basically the structural part. So what is happening? This structural part, remember you notice the sign here. This dilation definitely it's expansion, so it's basically like the addition. But something more than addition because here it's a two-dimensional element. So first what we will do, this 0 is there, so we will multiply this element with keeping here 1. But it will come 0. When 0 will multiply with every element 0, 0, 0, everything will be 0. When we will multiply, when we will shift it over the right hand side and when we multiply, 1 will come here, 1 will come here, 0, 0. So it will be 1 value here. In the same way, when we will move this small one inside it, that will also come. When this one will multiply here, so what will we get? We will get here this 1, 1, 0. So you see the change there. First of all, when we are multiplying here, this one, so this part has been added 1, 1, 0, 0. Why? This complete structure. Thereafter, this structure has changed into this one 0, 1, 1, 1, 0, 0, 0, 1, 0, 1, 1. I think there is some changes there. So it is actually 0 only here. So what is the case here? It is 0, 0 here. Then again, see, we will multiply this structure here. So what will you get here? When it will be multiplied here to this one, remember when it will be multiplied by this one, so this extra element when will append at the end. And this 0, 0 will come here. In the same way, when you will multiply this structure with this one, what you will get? 1, 1, 0, 0. So you will get here, it is 1, 1, 0, 0, and here it will be, here upper terms are fixed, so here lower terms are fixed, and it will be 1, 1, 1. Thereafter, you will get this term, and then you will again multiply it, you will get again 1, 1, 0, 0. So this is the case of the dilation. What about the erosion? In erosion, see again, see what we are saying. Erosion basically the as something is reduced. It is opposite to the dilation. What we are saying here that it removes the pixels from the boundaries of foreground. Boundaries of foreground in any way. What is happening? So this distance is there. It has been further reduced. So how does this operation take place? You can see its mathematics here. So for example, this original image is there. 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 0, 0. And here it is 1, 1, 1, 0. What will you get here? Here you will You have to check out that where this structural image is presented in the image. So where this element is repeated, if you see here, see this same pattern, 1, 1, 1, this is repeated here at one place. The same pattern is repeated here. So at both these elements, this 1, 1 is here. So that's why we will put up final one here and final one here. Erosion is actually like the division. See, whatever thing is there, actually we will remove it. So when we will remove it, so the remaining element, the new eroded image will be this one. Now we see the opening. In case of the opening, see what you are seeing. Opening is basically a morphological operation. Now it's not only about the shrinking and expanding, it is also about removing the object's noise by preserving the overall size and shape of the larger object. So what we are doing here, we are doing basically, we are eroding it. We are eroding it. So first you have basically initially eroded and then you basically dilate it. How will it occur? See, erosion basically, when you do the erosion, it will remove unwanted foreground pixel. Where? In this case, dilation restores the main subject shape. So what you can see here, you can see it here that this is original image, this is structural image. So what we are doing, so what is the sign of this minus? What is the sign of? The sign is basically of the, which is basically subtracting, which is removing the things. What is the sign of? The sign is basically of the erosion, right? So, and what about this one? This sign here actually we are dilation. First we are basically eroding and then thereafter we are doing the dilation. And it has resulted. So what we have done in the erosion. So if you see this structure, when we do the erosion, we need to find out the element, with central element where all the pattern comes up. So which points are there? So one point is this one. So you can see here, this is basically the, here we are subtracting it. So one here, when you will take this structure, so if you put one here, it will basically replicate here. And if you will put one here, at which two position? At this position and at this position. You are getting the one at here and also at this position. Will get this type of answer. So this is basically the opening, what you are closing. In closing, basically you do the dilation and you do the erosion. So basically these are the three different type of morphological operation that fills small holes and gaps inside foreground objects and smooth their boundary. It is also very important to we say manage the your figure, change the figure. So how do we do it? Here we do with the help of the structuring element. What do? We basically do the either two process. Basically, one is dilation, another is the elation. But important thing here that dilation is followed by the erosion. So what is happening here? So basically, you have uh, basically expanded it, and thereafter expansion, you have basically reduced it. So what it has been showing, it is showing in this operation. Any question, I think gradient. In gradient, actually, what we are doing in gradient, we are computing the difference between dilation. Which one is the dilation here? This is the one. So dilation expands object, subtracting the violate only the boundary region. And as we've already seen that also the gradient actually when we consider the different gradient like the Stobel gradient, Robert gradient, they all give the basically edges and boundaries. So this top hat operation, it extracts very small bright objects from an image that are smaller than the structural element. This is the top hat. What do you do? You do input image minus opening. So opening is smooth the image, remove the small bright region. Subtraction. So why we are doing the subtraction? Because it recovery those tiny bright features that were removed. That is about the top hat. What about the black hat? Black hat it means basically we extract small dark objects or gaps that are smaller than the structuring element on a bright background. So what we are doing here, basically closing. First of all, we will do basically the closing fills in dark hole. So here we can see that it closing fills tiny dark holes and smooths the object, and subtraction retrieves those removed dark regions. So in essence, what is the role of the morphology? Morphology when you do want to the small operations on image. For example, in the during the medical part, or when we want to take out the some specific region, or when to highlight the some specific region, there you clearly do the operation, but definitely it will alter the image. It will alter the original image. This is basically the black hat. What do you mean by the black hat? Black hat is basically the name that it extracts the small dark objects or gaps that are smaller than the structuring element on a bright background. So what is showing? That's why this input image is shown here. That bright background is there and it extracts the small dark object. That's we are here. See, we have reached it here. Base segment. Now see the question arises. See the first basic question that how will this image segmentation differ from the legal image processing like the erosion? What is the difference between, can you infer the difference between image segmentation and morphological operation of erosion? Any guess, any idea? So see, here actually the key difference in morphology, see erosion, etc. What you are doing, you are basically removing that portion. But segmentation, remember here actually you are extracting out some portion. There you are removing the portion. It is completely removal in erosion. Your remaining image actually is only useful. But in segmentation, you are basically creating the boundary, and that from the boundary you are taking that part. And why they are doing it basically to inform the object detection and related tasks. So what type of techniques are there? One is basically based upon the discontinuity, another is similarity. In discontinuity, it is the edge based, and from the edge based, it is the gradient based, it is the Gaussian based. Gradient, see, if you remember Sobel, Robert, Previtt, they, if you remember basically the mask that 1 1 1 1, in between it is 8. Then actually another case was there when it was taking the weighted average also. Kenny's detection, Laplace channel Gaussian. So before going to it in a segmentation, we will our problem. Just we recapitulated whatever we have done today in the morning. Any question? So now see, coming to the problems part, as we decided in the afternoon we will come. So this is basically the answer of the that problem which you got in the assignment. Anyone who has a query in this question, should I explain it again? Even see another problem is there. We check out here. So another this problem is there. Integration grayscale 5 by level range from 0 to 7. So how will we do it? Says total number of pixels they are using. You will see what apply the histogram equalization. So applying the histogram equalization will require to calculate. See what does it require? See, first it will basically the value of R of k is there. Thereafter R of k, what do you calculate? You calculate N of k. This is R of k and this is basically N of k. How much time it is repeating? That you have to take here. Then it will lead to the S of k. And n of k, sorry, is this s of k or it is something other thing? If you remember, it is, what was this value here? This PR of k. After PR of k, what is the value? Then you calculate basically CDF. Then what did you calculate? PDF have calculated, CDF have calculated. Then what? Then you multiply with the L minus 1. Thereafter, what we do, we basically round off. Here we round off. And here we get the new pixel value. So that you can see here. It is the same way. Peak is there, CDF is there, we multiply it and then we calculate the S of K. And then S of K is basically same, the mapped way. Any question? Again, histogram equalization, since you have done it, it is the same way. It shouldn't be difficult. We can again see the solution for histogram equalization after histogram equalization. But remember, the important thing here, it is a 4-point grayscale. So 4-point grayscale, it means what will be the value from 0 to 50. Here it has been shown here. So this way we are able to do it. So this is here. Another see example of the histogram equalization that has been shown here. If nothing is given, then you may take the 3 means n equal to 3. That would suffice. The problem, so same type of problem, that's all here we conclude. So this is our team. Our research team which helped to prepare to Ramniva, Manisha. See, Manisha has worked basically on the facial recognition, occluded facial recognition. Ramnivas has basically worked upon the EEG signals part. How to basically extract out the signal, how to infer the disease using the EEG signal processing. Suman is basically working on the brain tumor, MRI. Also, we are planning to extend our work using the EEG. Anand is very much communicated with him on the WhatsApp group, etc. He is working on basically the actually wave radar signal processing. Their image processing is also the part. This is the member which you have met actually. He is working on the hardware. This is about the so we take up some more problems, right? So if you have any question before it. I start with the problem, with a new problem. Any doubt, any question, just let me upload the next part. So if you have any question, just are you with me? Waiting for your any comment. Just please share your questions. Anything, whatever in morning, morphological, anything. Where are you with career about the content? Okay, good. So I want to take up some numerical. That's why it is actually some great. Whenever less questions are there, I seem to feel that whether should I need to cover it again or whether. So okay, see at this point of time, we at what purpose does computer vision be used? See, computer vision is basically, as we discussed in the first slide, that computer vision is basically to providing this automatic vision at a computer level or transferring that vision capability. For example, we took up the example of the driverless car. For example, some gate is there. As soon as the yes, it is used in medical diagnosis. Even we will take up the sessions on the medical diagnosis. That is basically the highest level of the computer vision. And then, just after say tomorrow, actually, we will conclude it. Then we will have the presentations on our application. From that Monday onwards, we will have a session on this thing only, our application only. So we come up after a break, just take a break because it can move to the new content and you come fresh again. Like So welcome you back. Am I, are you with me? Am I audible? Okay. Thank you, Saujanya. So now coming to the part here. What content we have covered yesterday that we will focus upon here. So now see, coming to this part, see now these are the problems, basically what we covered the content yesterday. So consider the following image strip of 19 pixels, compute its first order derivative and second order derivative. So which is this problem related with? Recall, see, are you able to get which is this one? So which is this content related with? I just open that part so that you don't feel that you are not connected. So this is the one. This is the problem. This is a related problem that we are reading. So what we are doing here, see, the aim is to emphasize. So what do you mean by sharpening the spatial filter? The aim is to emphasize the transitions in intensity. What do we do? We basically do use the Laplacian operator. What did we do? We do basically unsharp masking and high boost filtering. So using first order derivative for non-linear. So what is this formula? This is this one. Delta f upon delta x equal to fx plus 1 minus fx. And what about the second order derivative? This is fx plus 1 plus fx minus 1 minus 2f of x, right? So that we are doing here. So this image strip is given. So how we are finding out it? So basically, your first derivative, see what is this formula? It is fx plus 1 minus of f of x. So fx plus 1, so this value, this one, fx plus 1 minus f of x. So as soon as we improve towards the right, your x will basically increase. So here, see the first element, it is 0. The second element, see here 4 minus 5, it is minus 1. 3 minus 4, it is this is minus 1. So that's on. These values are there. Minus 1, 3, minus 2, it is minus 1. 2, 1 minus 2, it is minus 1. 0 minus 1 equal to minus 1. 6 minus 0 equal to 6. 0 minus 6 equal to minus 6. So that's why we are continuing. Are you able to understand? Are you able to understand this part? How it is going on? Exactly that same thing has been asked in that example. Before it's coming to some more problems are there so that you can see it here. So are you able to see the problem? Yeah. So what you are seeing on the screen? Which question number? 41. Thank you. So remember, see, this is another problem. So basically, before it, some more problems are there. So that's why so maybe we cover it for one and all the time. Describe histogram equalization. See, this is another problem. Again, see, as we have already done it. So this is basically the one. I quickly go through the one pixel values count is there. What is important? We will emphasize upon the differences. So what is the difference here? Difference here is basically this gray level, right? So how many bits are there? Can you guess how many? Because why the bits are important? Because that will decide basically the number of the gray level. What do you think? It is 3, 4, 5, 4 bits. If it is 4 bits, see, then it is 16. 2 raised to the power 4 equal to 16. But 18 is also here. 18 is there. 19 is there. Even see 16 also will can't be covered by it. So 16 you can cover till the 15 part only. So how many bits? 5 bits, absolutely. 5 bits are there. So once it is clear, so these are basically the 5 bits. So this is there, these pixel values are there. So here it is shown. This is 32. See, where is the role of this 5 bit? Because you will multiply. When you will multiply by the 31. CDF multiply by 31 here. When you will multiply here, so that is by 31, and then you will get it. This is the So after the histogram equalization, you will be able to. Another problem, a digital image with 8 quantization levels 0 to 7 is defined by the function fx y x minus y for x equals 0 to 7 and y 0 to 7. Resulting image is this one, write the final histogram equalized image. Even if you see this problem, so what has been asked here? It is 8 quantization levels is there. So that is fine. But what is only one thing is there, that this thing is given additional, but how does it play a role? We are very quickly going through the question. So what is its role? Any guess, any inference? What is the role of this function? Because this function was not given earlier. Are you with me? See, please feel free. Here, nothing is like no more any negative marking or nothing. Because only it is to basically encourage you so that you can maximum participate and you can think it on the line in which we are required to think. I am not here to say give any judgment, etc. You all are learner, even including myself. We all are here to learn it. Please feel free here. See what do you think? What could be the answer? Don't remain bound by this impression dilemma. See if you and any last call, you are able to do it. Ojanya, Jyoti, Shruti, Amrinder, Harish, Isha, Kartika. Exactly. See, if you really see it, if somebody will doesn't give me this matrix, that was not required. Actually, it has been provided in this question. Otherwise, if somebody write this question, we can form this matrix. How? Here, see, it has been given that x to y, it is basically 64 by 64 image, right? So 64, so you take any one. See, so what is here? This is here, this is 0, this is 1, this is 2, this is 3, this is 4, this is exactly given. This is 5, this is 6, this is 7. So what we are saying here, x value is 7 here and y value here is 0. Right? So since y value is 0, so 7 minus 0 is 7. So you can all build that matrix. Even see it was if this matrix was not given, we may form it with this relation. Otherwise, everything is same. Here it is gray level is there, number of pixel is there. Histogram equalization. For histogram equalization, again you need to calculate the CDF. So you need to calculate the CDF and then calculate by the L minus 1, where L is basically the level. So how many levels are there? What is the maximum level here? What is the capital L value? 64. See, just check out. See, 64 is basically the number of pixels. Capital L is basically the number of gray level. Yes, it is 7 actually. Why? See, because Yes, absolutely. Because as it is the 3 bits, maximum 3 bits are there, and with the 3 bits, so maximum level can be 8. So L is basically 8 here. So, so gray levels possible are 0 to 7. Same problem as you solved here. So it has been, this is capital L minus 1 and capital L is basically capital L is here equal to 7 and it has multiplied and we are able to calculate this. See 1 into 7, 1 into L minus 1, 7, it is given this. So I think this is the modified gray level. This is the metric. Are able to perform the histogram equalization for an 8 by 8 image shown below. This is basically the image here. So gray levels that is there. So we have to find out the number of. Again, see, I think you are able to do it. Is there any change for an 8 by 8 image? 8 by 8 image is there? Yes. But one thing is there that here gray levels are not given, so we will not able to form the new image. We will only able to tell the modified gray level, right? Okay, so we in the same way histogram equalization level. So this is shown here. So this is 1, 2, 3, 7, and this is the ones number of. Only you are able to tell the modified gray level. Right? Whenever we are solving the problem, we have to find out that what is something new. Something is new. Are we able to answer? Then we can go towards the new problem. Perform histogram equalization for the following image. Again, see this is the same problem. Again, you can do it. It's not difficult one. Again, see the level is it is fine. Gray level. So given below are to modify the histogram as given by histogram 2. Modify the histogram 1. Yes, this is the new. So what is this thing? Are you able to recall? What is this concept? Anyone from the participants? Not histogram equalization. This is not histogram stretching. What is this? What is this? Any last guess? Shifting? This is basically the histogram matching. Are you able to recall what was histogram matching? Yes or no? If two histograms are given, if somebody say that your this histogram is something which I want to learn from, then it is this problem. Go to the related theory part and see it where it is this one. Are you able to recall histogram matching? See, this is the one here. So what you are doing here, see, this was basically this wonderful technique that gray level was there and this round off was there, first and last column. And then you go to that round off value See this round off. So what you need to do? See, we need to find out the histogram exactly as like the histogram equalization in both the cases, and then one additional part is there. What is that additional part? So, see, what is that additional part here? Additional part is this. You have to take the first and last column of histogram B where the your graded level is there, and last two columns where round of value is there. And thereafter you have to take the new n of. So can we go back? Yes, we can go it here. See, this is now equalized histogram B. So here this is round off. So this is this value 1381. So this is this value. So what we are saying, it is 614. See, this is 1 has come to the 790, 3 has come to the 102, last two column. So you see this thing here. See, this is basically the gray level. This is 7 is there. 7 is basically the 448. So what is the problem? Given histogram will be modified histogram A. You have to modify histogram A as given by B. Basically, this will be modified. So it will be as given by B. So what will be the change? The new gray level. You equalize histogram B, and see what they have done. So they have done basically this is 13567. So 5 is going toward the 5 and 6 is toward the 6. So this is a basically matching. Check out the matching in this problem. So this is the problem. So this is the problem here. It is given. So 1267. So what do you need to do? First, you equalize the histogram 1, and histogram 1 basically what you have done. In histogram equalization level, you have find out the new levels, this one. And then you have find out the new n of what is, see this important, that here you find out the new n of k, that is this one. What is this new n of k and how it is different? See, because some levels, some modified level have the equal value. Two values are mapped to the same one, so that's why 6 and 6, it is basically 90. Initial one, it is the same, it is 0 to 1, but later on it is different. So in the same way, what is to be done here? So this is the equalized histogram 2. This is basically given here. Equalization level. And then see it is given 1, 2, 4, 6, 7. So this is basically the new level, and this is 1 will basically move towards the 1. 2 is also moving towards the 3. 4 is towards the 6. So see what is given here. See, this is so see what is given here. Equalize histogram 2. See this first of all gray value is given. This new value is given 1, 2, 4, 6, 7. Thereafter, this is 1, 2, 4, 6, 7, and this 1, 2, 4, 6, 7 is mapping basically 1 to the 1 and 2 to the 1. How they are mapping? Because you need to see the 1 here. In 1, what you are seeing that 2 is basically mapped to the 5. 1 is mapped to the 3. 1 is mapped to the 3, and 4 is mapped to the 3. Equalization level 1, 2. This is the fifth one. This is the sixth one. And then it is the seventh one. So thereafter it has done it. Then perform the histogram specification on the 8x8 level image described in table 1. What it is showing? It is showing here basically this is given, this is number of, this is given, this is number of basically. Pixel is given, target histogram is shown, so that is you can do it. So this is another histogram equalization. Again, then you are doing the matching. And then it is you are basically drawing it, and then you are equalization, and then you are finalizing it. Final map. For the 2-bit image, you determine the mean variance and the standard deviation. What is this problem? Determine mean variance and the standard deviation. What is this? So mean is basically we can find out it. How do you find out? So this is one of the formulas. See, this is important formula that this is important formula that this how the mean and variance are calculated. Ri into Pri and Ri minus m of a square, where m is basically the value of particular, m is basically the mean. So that way you are able to calculate the standard deviation in this one. Because see, whenever you are calculating this probability distribution function, if you remember, it is used to basically calculate the mean and variance. What is the role of the mean and variance? Mean and variance, see, that way you are able to basically extrapolate the data. That how does your data pattern look like? Another thing is see, a student has a grayscale image of landscape where the darker areas represent shadows and the lighter areas represent bright regions. The student wants to apply an intensity transformation on the image effectively to reverse the intensity level so that the shadows become bright and the bright regions become dark. Explain which transform should we use, apply the same transformation on the given image. Are you able to understand? See what it has been asked here. This is actually the we say the practical problem. Only here, see, if you notice the conditions, see what has been asked here. Shadows become bright and the bright regions become dark. See, this is basically the condition where it has been asked. So how will you do it? See, these are basically the real problems when you go through the basics. So are you able to? So this is our part that how we are applying the basics in the application. Any guess what you are going to do? Association, attribute. See, but actually which transformation? Transformation means basically see how R value is given, what we want to find out the S. So what should be the this formula of S? Inversion technique, yes, very good. See, absolutely. This is the inversion technique. You can apply basically see what is the See what you can do, inversion technique. Can you tell me the formula? Formula, see what can be the one here. So what the formula, maybe it is S equal to L minus R. Minus. Yes, it is. See this one image negation, it is there. So it is exactly we are doing it and we are able to do it this. So that is the way the problems are given. So once the somebody gives you the image, now you are in a position to tell the answer. For the following image, assuming the gray level is 0 to 7, determine the following inversion operation. It has been already told you that you can do it in this. Right, so this is given already, so it is the same thing. Square function. Somebody says that a square function is there. Somebody is saying we say the logarithmic operation, so that you can do. So only what you need to do, you need to simply put the value and you will find out the new scaled value. So it is only simply a calculation and you can do it. Only the thing which you need to keep in mind that even somewhere if point is coming, divide, etc., you need to round off that value to the whole integer value. Exactly. The add we had been discussing. This is the one. See here it is 1.39. So what would be the value? It is 1. This is 1.39 also here. So it is all basically the 1. I hope see it is well understood by everyone. Any question? I hope I'm not going very quickly. It is the same problem. Again, you see here, wherever this thing, this is 8.59. What will it do? What will be the complete value? This is the 9. Perform the log transformation on the image shown in figure 1. Assume the values of C equals to the number of plane in an image. Can you tell? Can you tell about this part? What would be the value? So see, what is the logarithmic transformation function? How many number of planes are there in an image? Any guess? I think people are very image conscious. This is a new topic we need to read. See, simple thing, when it is there, see log transformation against it, what would do? This is log 1 plus r. Assume the value of C equal to the number of plane in an image. See how many planes are there. Definitely, it is the see here, it is C log 1 plus r, it is one plane is there. Whether it is X, Y, Z, Y, whatever it is there. So this is, they have done it. Right. Obtain the third bit plane for the following image segment as shown below. Further generate a binary image by apply thresholding at 15 and write the image. What it is saying, obtain the third bit plane for the following image segment as shown below. Further generate a binary image by apply thresholding at 15 and write them. Are you able to recall? See which bit plane? It is now topic has changed. Are you able to recall one topic we did it? Are you aware about this topic, bit plane slicing? Are you able to recall bit plane slicing when you taken up either the MSB or the LSB or the central bit? So this is, see, bit plane slicing, right? Just we also do the session change because it is already 2 hours. So think about it. See, what did we use? If you recall, see, bit plane slicing was used for the compression. In the compression, we actually used it. And we took up the 8 plane, if you remember. And then one of the plane was sufficient, only 1 bit. So what do you need to do? You need to convert it into a. So how many bits are there here? Just rotation chain.